The second part was, what is the value for the rate constant K? Let's take the data away for a moment. Well, we have one equation, one unknown, so let's mathematically rearrange it for the part we don't know, for K. So it's rate divided by the concentration of nitrogen monoxide squared and the concentration of H2. Now, the way the problem was worded, it did say calculate the rate constant. It didn't specify any of the trials. It also didn't say calculate an average value. Now, the rate constant is supposed to be a constant, but because of experimental uncertainty in the data and because of rounding, you can get slightly different values of K depending upon which trial you pick. So for my classes, since I wasn't specific, you could pick any one of those 3 trials and calculate your rate constant. I'm going to go through and do it for each of the trials just to show you. So let's start with trial 1. And down below, there's the mathematical expression for K. So we'll take the rate, plug that in. Notice I'm using units now. Rate constants have units. You must use units. And you can't use the square brackets now, because the square brackets are a shorthand for concentration, but if you actually need the units, you have to plug the units in. See, look in the denominator. I didn't do square brackets around that because I have to put in the units of molarity, and it's that squared. I pull in the value for H2. And then I do the math. I get 260. What about the units? Well, a molarity cancels in the numerator and denominator, so we're left with units of reciprocal molarity squared seconds. If you want to break down the molarity into moles per liter, you would write it like this. You have to include the units on the rate constant because different chemical equations that have different rate laws, different exponents, will have different values for the units. Well, let's calculate the rate constant using trial 2 data and see what happens. Take the rate, put the units in, concentration of nitrogen monoxide, concentration of H2, and then, just like last time, we get 260. And one more time for trial 3. Take the rate, concentration for nitrogen monoxide, concentration for H2, and this time we get 250, not 260. That's what I mentioned about rounding issues and experimental uncertainty leading to slightly different values, possibly, depending upon which trial you pick. So here are the 3 values that we calculated.